Hi everyone, we're now in section 8.6, Systems of Nonlinear Equations. So what we're going to do is now solve systems that involve powers of x that are maybe greater than 1 or not equal to 1. This first one's asking us to solve it by graphing. So remember that when you are solving a system, what you're finding is the point or points of intersection. Since these are not lines, there could be more than one point of intersection. So for this first example here, this is a line, 2x plus 4. So let's go ahead and plot the points. The y-intercept is 4, and the slope is 2. So I'll use rise over run to find more points here. So the y-intercept is 4, the slope is 2, so I have this increasing line here. And then this next equation, you might not recognize immediately what this is. It's actually the top half of a circle, and let me show you how you can see that. If you have this equation of a circle, this would be a circle centered at the origin with radius 2. So if I solved this for y by subtracting x squared and then taking the square root of both sides, I would get y equals plus or minus the square root of 4 minus x squared. But this one doesn't have the plus or minus, so if it's just the positive version, that would be the top half of the circle. So let me write this down, top half of circle with center the origin, 0, 0, and radius 2. So let's go ahead and plot that. I would know these 3 points at least. The center is 0 and the radius is 2, so I could go left, right, up, and down 2. And then I could draw in my semicircle. So you can see here that this line intersects the semicircle at 2 points, here and here. But by graphing, I can't really identify the coordinates of that second one. This one, of course, we can tell is negative 2, 0. But this one, I don't really know based upon just looking at it. So obviously, graphing might not always be the best option for solving a system of nonlinear equations. So what we can do is try doing this algebraically. So there's a couple more examples here where we can try an algebraic method. And by algebraically, I mean using substitution or elimination, and you can choose whichever one you want. Sometimes elimination is not an option, and this is one of those cases, especially if you see a term like this that has x and y in the same term. Elimination really wouldn't work for that, so for this particular problem, we're going to use substitution. So what I want to do is, in this second equation, isolate either x or y, and then substitute it back into the top equation. Looking at the top equation, I think it might be easier to substitute for x. And the only reason I'm saying that is because there's a y squared and there isn't an x squared. So I'm going to solve for x and then do substitution. Okay, so if I take this equation here on the bottom, 2x minus 3y plus 4 equals 0, I can now solve this for x. So I will add 3y and subtract 4 to the other side, and then divide by 2. Okay, so I've isolated x. X equals 3y minus 4 over 2. Now I'm going to go to the other equation, and everywhere I see x, so here and here, I'm going to replace it with 3y minus 4 over 2. So I will write my substitution step over here. So I have 2y squared minus 3. Instead of x, I'm writing 3y minus 4 over 2 times y plus 6y plus 2 times x, which is 3y minus 4 over 2 plus 4 equals 0. So by doing substitution, I've now been able to rewrite the equation as an equation with only y in it, so I can now solve this for y. So let's see if we can clean this up a little bit first. It's a little bit messy. I am noticing some cancellation here, 2 over 2, so that's good. That will be one less denominator. Okay, so I have 2y squared minus, I'm going to distribute the 3, I'm probably going to distribute it into the numerator there. So I have, actually it's a negative 3. I'm going to distribute the negative 3 halves. So it'll be minus 9y over 2 plus 12 over, oops, sorry, that's squared. 9y squared over 2 plus 12 over 2y. That will be a 6, so that's good. We can fix that in the next step. Plus 6y plus 3y minus 4 plus 4 equals 0. So all I did in this step was I took this 3/2 here, this negative 3/2, and I distributed it up there. Okay, now let's see if we can combine like terms. So I have 2y squared and minus 9/2 y squared. So 2y squared is the same as 4 over 2y squared. So that'll be negative 5 over 2y squared. Plus 12 over 2y, that's 6y, plus 6y, that's going to be 12, plus 3, so 15. So plus 15y, and then minus 4 plus 4, that's 0. So it became simplified quite a bit. If you don't like the way this looks with the negative and the fraction, you can fix that if you like. I think I will. I think I'll multiply both sides by -2. It's an equation, so I'm free to do that. So I will get here 5y squared minus 30y equals 0. I just like the look of that better. Now I'm going to solve this by factoring, so I'll factor out 5y. So 5y times y minus 6 equals 0. So 5y equals 0, or y minus 6 equals 0. So y equals 0, or y equals 6. So remember that this corresponds to points of intersection, so the y values really are only half the answer. We do also need x values, so we can write these as ordered pairs, or coordinates of points of intersection. The easiest way to do that would be to take these and to go ahead and go back to this other equation that we were working with earlier and just plug in for y. So if y equals 0, what x value corresponds to that? Well, we can find that out by plugging it in. 3 times 0 minus 4 over 2. So x equals negative 4 over 2, which is -2. So this gives me one point of intersection. It would be the point -2, 0. Okay, so it's one of the solutions. Now for the other one, I will plug 6 in for y. So 3 times 6 minus 4 over 2. So x equals 18 minus 4, which is 14, over 2, which is 7. So the other point of intersection would be the point 7, 6. So these two graphs intersect at 2 points, the points -2, 0 and the point 7, 6. I mentioned earlier that sometimes you can do elimination. If you look at this example here, this is one of those times I believe I could use elimination to eliminate the x terms. If you look at the x terms here, 2 over x squared, 6 over x squared, I think I can get them to have opposite coefficients. Since this is a 6 here, I can turn this into a -6 by multiplying the top equation by -3. So I think I will do that so that I can do elimination. Elimination is usually quicker than substitution when it's possible. So I'm multiplying both sides of this equation by -3. So I'll distribute it here to all these terms, and then of course -3 times 0 is 0. So let me rewrite it over here. I have -6 over x squared plus 9 over y squared minus 3 equals 0. So I've multiplied every single term in that equation by -3. Now I will rewrite the other equation below it, which I'm not changing at all because these have opposite coefficients, which is exactly what I wanted. And now I will do elimination by adding these two equations together. So what's getting eliminated is this first term. -6 over x squared plus 6 over x squared is 0. Then I have 9 minus 7, 2 over y squared, minus 1 equals 0. So I want to solve this for y, so we'll add 1 to both sides. So 2 over y squared equals 1. We can multiply both sides of the equation by y squared, and we'll get 2 equals y squared. And then taking the square root, plus or minus the square root of 2 equals y. So this one has two solutions for y, the square root of 2 and negative square root of 2. So we need to find the corresponding x values, so we can plug those back into either of these equations and then find the corresponding x values. So it doesn't really matter which one you use. I guess I'll just use the top one. So 2 over x squared minus 3 over, now I know what y squared is. It's right there. Y squared is 2. So I'll go ahead and replace y squared with 2. Plus 1 equals 0. Negative 3 halves plus 1 is negative 1 half. And then I can go ahead and add that 1 half over. And I have a single fraction equal to a single fraction, so I think I will cross multiply. So I get x squared equals 4. I'm doing cross multiplication. So x equals plus or minus 2. So this would have been the case whether or not we plugged in square root of 2 or negative square root of 2. So what we're really getting here is we're getting 4 possible points of intersection. So let's go ahead and write them all out. So for the positive for the positive 2 value of x, we could have mapped to the square root of 2 or the negative square root of 2. And that's the same for the negative 2 value of x. So these two graphs would intersect in 4 different locations. We have one example left here. It's a kind of a small word problem. So let's go ahead and translate this to a system of equations. The product of 2 numbers is 10, and the difference of their squares is 21. Find the numbers. So product refers to multiplication. It's 2 unknown numbers, so I'll use x and y. So x times y should be 10. The product of 2 numbers is 10. The difference of their squares is 21. So if you square them and subtract, you should get 21. So here is my system of equations. I really don't have any other choice but to do substitution. So I need to isolate x or y. I'll probably do that in this first equation. So let me go ahead and just solve for y by dividing both sides by x. So y equals 10 over x. Now I can take that and substitute for this y over here in the second equation. So x squared minus 10 over x squared equals 21. So I want to solve this for x. So let's go ahead and actually get rid of the parentheses by squaring the numerator and denominator here. Then I prefer to get rid of the fraction, and I'll do that by multiplying by the LCD, which is x squared. So multiply both sides of the equation by x squared, and I will get x to the 4th minus 100 equals 21x squared. I'm hoping this is factorable, and I won't know that until I get 0 on one side, so I'm going to subtract 21x squared. I'm going to reorder the terms. And looking at these numbers, I'm seeing that it is factorable. This is what we called before a quadratic type equation. It has the structure of a quadratic equation, even though it's degree 4. So I'm going to look at factoring this. It would be x squared as the first term for each binomial. And I had two numbers whose product is negative 100 and whose sum is negative 21. So I think the numbers that work would be minus 25 and plus 4. So if I set each of these factors equal to 0, I'm going to get some solutions here. So I'm getting x equals plus or minus 5. For this one, I'm going to get imaginary numbers, so no real solutions from that factor. So I'll just stick with these, x equals plus or minus 5. So that would be one of the two numbers, 5 or negative 5. We need to find numbers that match that. We can do that by resubstituting back in. So I have this equation from earlier. So if x is 5, then y would have to be 2. So the two numbers could be 5 and 2. The other possibility is what if x is negative 5? So I replace x with negative 5. So the other possibility would be negative 5 and